Hi everybody. Today's lesson we are moving on from interference and starting the next part of waves, which has to do with standing waves. Now before we learn more about standing waves, let's look at what we already know, and that's about traveling waves. So traveling waves are going forwards, and what they do is they carry energy from one part to the other without the medium itself being transferred from one part to the other. The only thing that happens in a traveling wave is localized movement. So the particles are just either moving up and down, or the particles are moving back and forth. So I'm just noting things down as I'm talking. So the first function of a traveling wave is to transfer energy. Okay, the other thing about a traveling wave is that a traveling wave consists of crests and troughs. So that's your traveling wave going forward. So the top points are your crests, the bottom points are your troughs. So it consists of crests and troughs. Now, the very fact that a traveling wave is transferring energy, the way that this is done is that as the particle vibrate, each particle is doing work on its neighboring particle to transfer energy. That's how the energy goes from one layer to the other. Okay, so each particle does work on the neighboring particle. And it does this to transfer energy. Okay. Now the other thing about a traveling wave, and which I'll show in class, is using the wave machine, that the particles are in simple harmonic motion, but you will notice that all the particles are not doing exactly the same thing. Each particle is kind of out of step with its neighbor. So we call there is a phase difference between adjacent particles. So So these are some of the things about traveling waves. Now, as opposed to that, let us look at standing waves. So a standing wave is actually formed when you have two traveling waves coming in opposite direction and they occupying the same position at the same time. And so the resultant waves seem to not go anywhere, but it's just standing there. And as a result, so instead of transferring energy from one end to the other, you see the energy is coming from two different directions. And so all the energy is contained in a standing wave. So all the energy is actually trapped in the wave. So energy is trapped in the wave. And because it's to do with two waves going in opposite direction, and in order to get a pattern, you get a pattern when you have both the waves with the same amplitude, same frequency, same wavelength, when everything is same, okay, when they are coherent. So the way that we represent a standing wave is like this. So you've got one traveling wave going one way, and then you've got the other one going the other way. So they're moving in opposite directions, and we tend to do it like this. And so what happens is when waves travel through each other, they interfere with each other. So a standing wave is a result of interference. It's an example of interference. And so instead of consisting of crests and troughs, areas of constructive interference are called antinodal points, and areas of destructive interference are nodal points. So you've got the alternate nodes and antinodes in a standing wave. Now the thing is, you can actually decide where do you get a node, where do you get an antinode, which comes back about reflection of a traveling wave. If a traveling wave is reflected off a fixed or a hard boundary, so what goes as a crest will come back as a trough. So there is what we call a phase reversal. So at a hard boundary, the medium is not free to move. So what you get is a node, okay? So it's a fixed end. However, If it is a loose end and the medium is free to vibrate, a traveling wave, what goes up as a crest will come back as a crest, so you have a doubly high crest, so you have an antinode there. Okay, so free ends you have antinodes, fixed ends you've got nodes in a traveling wave. Now the thing is, in a standing wave, unlike a traveling wave, because all the energy is trapped in the wave, all the particles in one half of the wave are in phase. Now, what do we mean by one half of the wave? This is one wavelength, a crest and a trough. So from here to here is one half of a wave. So that's one half, two halves, that's a whole wavelength. What I've drawn here is 1.5 wavelengths. So all the particles in one half of the wave are all moving in one direction. They are in phase, and all the particles in the opposite, in the adjacent half, are in opposite phase. Okay, so that's what we have to do with standing waves. So that's the basic difference between traveling waves and standing waves. Now, why are we learning about standing waves? I know a lot of people who do physics also do music. Somehow they seem to go together, and all these musical instruments, they resonate or they produce these sounds because of standing waves that are set up. So if you pluck the string of a guitar, what actually happens is, yes, you see the string vibrating up and down, but what happens is the incident wave and the reflected wave gets traveled through each other to produce a standing wave. And the sort of standing wave that's produced actually depends on, are the ends fixed or are the ends open? So you can have standing waves set up in organ pipes, in guitar string, any musical instrument. Okay, but the thing is, the only waves that will resonate in a string or pipe is the one that fits the restrictions of the medium. When we say fits the restrictions, it depends on the length of your string or pipe. You know, your piano strings, you've got little strings and you've got long strings, you've got thick strings and you've got thin strings. Same again with the flute, you can have all the holes depending on which ones are open, which ones are closed. Okay, and also it also depends on the other restriction is, are the ends closed or are they open? You can never have two closed ends, because even with the flute or anything, you've got to blow through one end. Okay, so you can have strings that are fixed at two ends, or a string that's only fixed at one end. You could have pipes like organ pipes. You can have pipes that are open at both ends, or you could have what we called a closed pipe, which is closed at one end and open at the other. And that's going to be the topic of our next lesson. And I hope this made sense. So bye for now.